So I'm going to be demonstrating some quantum effects in Minecraft. So the first one I'm going to be demonstrating is entanglement. So I've created these pairs of particles so that if I apply the same measurement to both of them, one will always be lapis and the other will always be gold, if I do it on the same axis. Without measuring, there's no way to know. But if I measure them in opposite directions, as you'll see here, they both turn out to be the same, always. But if I measure them on different axes, then as you can see, sometimes they turn out to be the same, but sometimes they turn out to be different. Watch. Lapis, but this one is gold. Now I have something more interesting. These are electrons, which are fermions, meaning they have an odd half-integer spin. If you haven't noticed, they can't stack. You can't put them in the same state. But what happens if you try to? Well, if you apply a ton of pressure to them, and I'll load them into this box, and then squeeze this box really hard so they stay in it, this is what happens. It's a phenomenon known as degeneracy pressure, and it happens due to the Pauli exclusion principle. And here, if you cool it down enough and put ice around it, the electrons start to behave as one particle. They form pairs known as Cooper pairs. But if you take the ice away, then they will turn back into electrons. This block is in what's called a superposition. It's in multiple states at once, in this case, a lapis and gold block at the same time. It doesn't stay lapis long enough for you to measure it as such. I'm going to see what happens if I measure this superposition. Let's see what happens. Oh, it broke the measuring device. Let's see if we can get it to collapse to... Oh, we have. It's still in superposition, though. So what that means is that this is all the same particle. That's messed up. So that means if I mine one, they'll all go. Cool. This is the wave-particle duality. Right now, you can see the wave function, which is the mathematical description of the probability distribution of the particle being in a specific location. And you can see that as it goes away, the uncertainty value decreases until eventually the particle shows up. So if you have this particle in this box here and you add enough pressure, it can escape the box because it gains enough energy to do so. If I have a wave function and I put a barrier around it, then due to the uncertainty principle, there is a small chance that that particle will actually turn up outside of the barrier. So let's wait. This is also what leads to radioactive decay. Bam.